Tonight, we're going to the farthest place a human being has ever been. It's not as far as you might think. The moon, about 3 days away, if everything goes well. A little less than 400,000 kilometers. That's it. That's the edge. In all of human history, no one has ever traveled further from Earth than that. We've sent machines much deeper into space. Probes have reached the outer planets, drifted past the edge of the solar system, and are still traveling now, decades after they launched. But humans? We've only ever touched the moon, and we haven't been back in over 50 years. Space looks crossable on maps. The diagrams in textbooks show the planets lined up neatly, almost close enough to hop between. But those maps are kind. They compress distances that in reality stretch beyond anything a human life can easily cross. Mars, the closest planet we dream of reaching, would take 7 months just to get there. 7 months of drifting through nothing, carrying everything you need, with no way to stop and no way to turn back quickly. And Mars is close. The outer planets are measured in years, the nearest star in tens of thousands. There's a boundary out there somewhere, not a wall, but a kind of quiet limit, a point where distance and time and the needs of a human body start to pull against each other, and the universe gently makes clear what it will and won't allow. Tonight, we'll drift toward that edge. We'll ask how far a person could truly go and what it would take to get there. And we'll sit with the strange comfort of knowing that some distances exist simply to be wondered at. Before we begin, I'd love to know where you're listening from tonight and what time is it there. I always imagine this calm little community scattered like starlight across the globe, sharing the same story beneath different skies. If these gentle journeys bring you peace, a like or subscribe helps others find their way here too. Now, let your breath slow, let your body settle, and together, let's drift toward the edge of how far we can go. Once the first steps away from Earth are behind us, the meaning of travel begins to change in a way that is easy to miss at first. On Earth, distance feels solid and intuitive. A place is far because it takes time to reach it, and time is shaped by speed. Roads shorten when engines improve, oceans shrink when ships grow faster, and the world feels smaller because movement carries us continuously towards somewhere else. Space does not behave that way. Distance, speed, and time loosen from one another, no longer braided into a single experience. They become separate presences, drifting apart, each obeying its own quiet rules. In space, covering distance does not feel like movement through scenery. It feels more like waiting while the universe slowly slides past, almost imperceptibly, as though travel itself has become abstract. Speed in space is not the same as speed across a surface. On land or water, motion is constantly shaped by friction, gravity, and resistance. Movement is effort sustained moment by moment. In space, once motion begins, it mostly continues on its own. After the brief violence of launch fades, after the engines fall silent, the spacecraft enters a long, gentle drift. There is no wind to push against the hull, no ground rushing beneath the feet, no steady sense of progress. Velocity becomes invisible. A ship can be moving faster than any aircraft ever built, yet feel completely still inside. Nothing vibrates, nothing leans, objects float exactly as they did before. Speed exists only as a number, not as a sensation, and without sensation, the human mind struggles to treat it as real. This is where acceleration becomes the true act of traveling. In space, acceleration is precious and rare. It is the brief moment when energy is spent, when fuel is burned, and when motion is changed. Everything else is coasting, an extended glide across emptiness. A spacecraft accelerates for minutes or hours, sometimes less, and then it drifts for months. Direction and velocity are set early, like a stone released into a vast dark lake. From that moment on, the journey is mostly passive. Adjustments are small and careful, tiny corrections measured in whispers of thrust rather than bold acts of motion. Travel becomes less about going and more about enduring the passage of time while moving. Because of this, time becomes the dominant presence aboard any long journey. Not clock time alone, but experienced time. Days stretch as routines repeat without change. Outside the window, the view barely shifts, stars holding their patterns, distances remaining stubbornly abstract. There is no rising horizon, no approaching shoreline, no visual cue that arrival is creeping closer. Unlike crossing a desert or sailing an ocean, where subtle changes mark progress, space offers almost nothing to measure against the body's senses. Movement happens on scales too large and too slow to feel. The mind waits for motion that never announces itself, and gradually learns that travel here is not a sequence of events, but a prolonged state. Most of a space journey is therefore spent doing almost nothing at all. Systems hum softly. Instruments confirm that the trajectory remains true. Crew members float, sleep, eat, exercise, and watch numbers inch forward. There are moments of activity, scheduled burns, alignment checks, quiet confirmations that everything remains as planned. But these moments are islands in a sea of stillness. The vast majority of the voyage is absence rather than action. Distance is crossed not through effort, but through patience, through allowing time to carry the vessel where initial acceleration already aimed it. This inversion of travel challenges instincts shaped by millions of years on Earth. The body expects motion to feel like effort repeated. The mind expects distance to reveal itself through change. Space offers neither. It asks travelers to accept that progress can be silent and invisible, that arrival depends less on what is done along the way and more on what was done at the beginning. In this environment, travel is no longer a story of constant movement forward, but a quiet surrender to trajectories chosen long ago. The journey unfolds without landmarks, without milestones, and without reassurance from the senses, as time stretches outward and distance becomes something crossed not by motion, but by waiting. As the meaning of travel stretches thin and abstract, speed quietly takes center stage, not as a thrill, but as a measure of how briefly we have ever outrun our home. The fastest humans in history did not feel fast in the way motion usually announces itself. Inside the Apollo spacecraft, there was no rush of wind, no visible blur, no rising landscape falling away beneath their feet. The engines burned, the numbers climbed, and Earth slowly grew smaller, but sensation lagged far behind reality. At their peak, those crews were moving faster than any people ever have, faster than rifles, storms, or sound waves racing through air. Yet inside the cabin, life unfolded calmly, almost gently, as though speed itself had become something purely intellectual. What mattered was not how it felt, but what it accomplished. In a short span of hours, they climbed free of Earth's hold, slipping beyond the familiar grip that shapes every movement on the surface below, carrying their momentum outward into a domain where speed no longer behaves the way intuition expects. Measured against everyday experience, those velocities feel astonishing. A commercial jet crossing continents seems swift because landscapes scroll beneath it and hours collapse into moments. A car feels fast because the body leans into turns and the road hums beneath tires. The Apollo crews left such scales behind entirely. They crossed distances that would take days at highway speeds in mere seconds, accelerating upward until cities, continents, and oceans compressed into a single pale curve. It is tempting to imagine this as a kind of triumph, as though sheer velocity itself might unlock the universe. But speed in space reveals its limits almost immediately. Once Earth fell away, even these record breaking velocities began to feel small. The Moon, despite being our nearest cosmic neighbor, still demanded days of travel. Motion continued, steady and relentless, yet arrival remained distant, reminding those aboard that even the fastest human journeys barely skim the edges of the vastness around them. When compared to the scales that rule the cosmos, human speed becomes almost delicate. Light itself crosses the space between Earth and Moon in just over a second, and even that luminous pace slows to a crawl when stretched across the gaps between planets, stars, and galaxies. The Apollo crews, moving at their historic maximum, would need years to reach the outer edges of the solar system if they continued on, and tens of thousands of years to approach even the nearest stars. The numbers grow quietly, without drama, each new distance multiplying time beyond the span of a single life, or even a culture's memory. Speed, no matter how impressive it feels at human scales, does not accumulate fast enough to conquer cosmic separation. It reveals that movement and reach are not the same thing, and that velocity alone cannot compress a universe designed to unfold over immense stretches of time. This is why those record speeds, remarkable as they are, shift so little in the larger picture. They allowed humans to step briefly beyond Earth, to touch another world, and return with stories etched into history, but they did not fundamentally alter our position among the stars. The difference between standing still and moving at our fastest turns out to be modest when measured against cosmic distances. It is like taking a single confident step into an endless ocean, meaningful and bold, yet still close enough to shore that the waves remember where you came from. The universe does not resist human speed with force or hostility. It simply remains vast, patiently indifferent, letting even our fastest journeys unfold at a pace that barely dents its scale. Within this realization, speed becomes something quieter. It is no longer a promise of conquest or escape, but a brief expression of what human ingenuity can momentarily achieve. Those Apollo velocities were enough to lift us away from Earth, enough to show that our home is not the center of motion, but a moving island drifting through space itself. Beyond that, speed settles into its true role, not as a key to boundless travel, but as a fleeting bridge between worlds that remain, in every meaningful sense, far apart. As speed settles into its quiet place within the story, distance begins to stretch again, revealing itself not as a single gap to cross, but as a layered vastness that unfolds step by step. The solar system often appears familiar, almost cozy, its planets memorized from childhood diagrams, where colored orbits loop neatly around a glowing sun. Those images offer comfort, a sense that everything sits within reach if only the right path is chosen. In reality, the space between those worlds is where the true scale hides. Each planet exists in its own wide silence, separated not by dramatic obstacles, but by emptiness so deep that it quietly overwhelms the imagination. The distances are not merely larger than expected, they are structured in ways that defy how the human mind naturally measures space. Diagrams have always been kind to us. They compress reality so that relationships can be seen at a glance, but in doing so, they quietly erase the experience of separation. Planets are drawn as neighbors, their paths almost brushing against one another, when in truth each world occupies a realm of space large enough to contain millions of Earths without touching. If the solar system were reduced to the scale of a room, the sun would shrink to something like a grain of dust, while the planets would become almost impossibly small motes scattered across distant corners. Most of the room would remain empty, not because anything is missing, but because emptiness is the dominant feature. That emptiness is not dramatic or threatening. It is simply there, vast and patient, asking travel to stretch across it without landmarks or reassurance. This hidden scale reveals itself slowly when measured in time rather than imagery. Reaching the inner worlds requires months of careful drifting, while journeys outward lengthen into years. Spacecraft bound for the outer planets do not rush through a sequence of destinations. They depart once, accelerate briefly, and then settle into long passages of silence. Days blur into months as the sun dims from a commanding presence to a bright star among others. The distances do not feel conquered so much as endured. Even at the highest speeds we have achieved, the outer planets remain far enough away that a journey there becomes a chapter of a life rather than an event within it. Time stretches, not because motion slows, but because space itself unfolds in a way that refuses to be hurried. As the years accumulate, expectations begin to shift. The solar system stops feeling like a collection of nearby places and begins to resemble a vast archipelago, with each world separated by oceans far deeper than any on Earth. There are no halfway points where relief waits. Every mission must carry its own endurance from beginning to end. Communication grows delayed. Plans must anticipate problems years in advance, and return becomes a concept rather than a certainty. This is not yet interstellar space, not yet the realm between stars, but even here the conditions quietly rewrite what travel means. The solar system alone demands patience on a scale that human stories rarely consider. What emerges from this gradual realization is a subtle recalibration of ambition. The idea of casually moving between worlds dissolves, replaced by an understanding that each outward step multiplies commitment. Exploration becomes deliberate and rare, shaped less by desire and more by what time allows. The solar system does not resist exploration, but it does not make it easy either. Its vastness acts like a filter, allowing only the most carefully prepared journeys to persist long enough to reach their distant goals. In doing so, it gently teaches that space travel is not about crossing lines on a map, but about accepting the quiet immensity between points. By the time these distances settle into awareness, the solar system no longer feels small or familiar. It becomes a reminder that even our immediate cosmic neighborhood is far larger than instinct suggests. Before considering stars, galaxies, or the deeper structure of the universe, expectations are already reshaped here, among the spaces between planets. The realization unfolds softly, not as a sudden shock, but as a patient widening of perspective, revealing that even close to home, space remains profoundly, humblingly vast. As the solar system's scale settles into the background, another presence quietly asserts itself, less vast but far less forgiving. Fuel does not feel poetic or distant. It is immediate, heavy, and absolute. Every journey outward begins with a simple truth that cannot be negotiated away. Anything leaving Earth must carry not only a destination, but the energy required to escape, steer, and survive along the way. Unlike travel on land or sea, there is no external source to lean on once the engines ignite, no currents to ride indefinitely, no winds that strengthen with patience. Space offers no help at all. Everything required for motion must be brought from the surface, lifted against gravity before the voyage even begins, stacked layer upon layer inside the vehicle itself. This creates a quiet and deeply counterintuitive problem. Fuel has mass, and mass requires fuel to move. Adding more propellant does not simply increase capability, it also increases the burden that must be carried. Each kilogram brought aboard demands its own share of energy, and that energy must also be stored as more mass. The relationship is not gentle or linear. It compounds. To gain a small increase in speed, much larger increases in fuel are required. Engineers have long understood this not as a philosophical idea, but as an unforgiving mathematical reality that shapes every rocket ever built. It is sometimes called the rocket equation, but in practice it feels less like an equation and more like a gravity well of its own, pulling ambitions back toward Earth. This is why rockets appear so large and spacecraft so small. What reaches space is only a fraction of what leaves the ground. Most of the vehicle exists to push fuel upward long enough for that fuel to push something else. Stages peel away one by one, shedding empty tanks like exhausted limbs, because carrying dead weight any farther would quietly doom the mission. By the time a spacecraft begins its long coast through space, almost everything that made launch possible has been discarded. What remains is light not by choice, but by necessity. Within this constraint, the idea of simply going faster begins to unravel. Speed demands energy, and energy demands mass, and mass demands more energy still. Each attempt to push beyond current limits runs headlong into diminishing returns. There is no moment where technology smoothly unlocks unlimited velocity. Instead, progress becomes asymptotic, each gain smaller, more expensive, and harder to justify than the last. Even exotic fuels and advanced engines are bound by this same quiet structure. They may shift numbers slightly, but they do not rewrite the relationship itself. Physics does not forbid greater speeds outright, it simply makes them extraordinarily costly in ways that accumulate faster than human engineering can comfortably follow. Refueling in space is often imagined as a solution, a way to break free from Earth's deep gravity well and start fresh farther out. In principle, it sounds straightforward. In practice, it introduces its own maze of challenges. Fuel must be placed in orbit before it can be used, which requires fuel of its own to get there. Transferring propellant between vehicles in microgravity is slow, delicate, and risky, with no room for leaks or errors. Storage is not passive either. Cryogenic fuels boil away over time, even in the cold of space, quietly thinning reserves long before they are needed. Infrastructure must be built and maintained in an environment that does everything it can to degrade machinery, while offering no natural resources that are easily accessible. Mining fuel from other worlds sounds like liberation, but even that vision remains bound to energy costs. Extracting materials requires heavy equipment, power sources, time, and repeated transport cycles, each step adding complexity and vulnerability. The universe does not offer convenient refueling stations waiting to be activated. Every option must be constructed deliberately, piece by piece, with energy paid up front and risks carried long afterward. Fuel becomes not just a substance, but a long-term commitment that shadows every decision. Within this web of constraints, fuel quietly becomes the first hard limit, not because it ends exploration, but because it defines its shape. It decides which paths are reasonable and which fade into theory. It slows ambition without drama, reminding explorers that motion in space is never free, never casual, and never separate from the mass that makes it possible. Long before radiation, isolation, or time take their toll, fuel has already drawn the boundaries of the journey, patiently and without exception. As fuel quietly defines how far motion can reach, time begins to speak in a more intimate voice, one that belongs not to spacecraft or equations, but to the human body itself. Long journeys do not unfold against an abstract calendar. They unfold against cells that divide, organs that adapt slowly, and minds that measure experience in seasons rather than distances. A human lifespan is not simply a number, but a rhythm shaped by growth, maturity, and gradual change. When travel stretches beyond a few years, that rhythm becomes impossible to ignore. A voyage that lasts decades does not pause life, it becomes life, unfolding within bodies that continue aging regardless of where they drift. Across the vast distances already described, time expands faster than the body is built to accommodate. Even within the solar system, reaching the outer regions demands spans long enough to carry a person from youth into middle age or from vigor into quiet decline. The journey itself becomes the dominant chapter of a life, absorbing years that on Earth would be marked by milestones, relationships, and slow personal evolution. Biology does not treat this as an adventure. It treats it as duration, as extended exposure to conditions far from those under which humans evolved. Muscles, bones, immune systems, and senses all respond to time spent away from gravity, sunlight, and familiar cycles. The longer that time becomes, the more those responses accumulate, often subtly at first, then with increasing permanence. Multi decade journeys matter because they intersect with limits that cannot be trained away. The human body repairs damage slowly, and its ability to do so declines over time. Small stresses that might be manageable over months or a few years begin to stack, interacting in complex ways that are difficult to predict or reverse. Healing slows, resilience thins. What begins as adaptation gradually gives way to vulnerability. Even if technology could shield against many external dangers, it cannot stop time from passing through tissue, memory, and identity. Aging continues quietly, without regard for mission timelines or destinations. The psychological dimension of this passage is just as persistent. Long missions replace the open future of a life with a narrow corridor of routine. Days repeat with little variation, bounded by metal walls and unchanging stars. The mind, evolved for rich social environments and shifting sensory input, must learn to live with constancy. Over years, this constancy can reshape perception itself. Memories of Earth soften and blur, while the present stretches outward, long and unbroken. Motivation shifts from achievement to maintenance, from progress toward goals to the simple act of continuing. Purpose becomes something that must be actively preserved, not assumed. Isolation compounds these effects. As distances grow, communication with Earth slows and immediacy fades. Conversations arrive delayed, out of sync with the emotions that sparked them. Shared time fractures. Support becomes abstract, carried by messages rather than presence. Over decades, this separation can alter the sense of belonging that anchors identity. The traveler remains human, but increasingly detached from the flow of life that shaped them. This is not despair or drama, but a quiet thinning of connection that deepens as years pass. Aging, in this context, becomes more than a biological process. It becomes a clock that ticks alongside the mission, indifferent to its success or failure. Each year spent in transit is a year not spent building resilience for what lies ahead. Arrival, if it comes, does not reset this clock. It delivers a person older than when they departed, with fewer reserves of strength and adaptability than they once possessed. The body carries the history of the journey within it, etched into bone density, cardiovascular capacity, and neural plasticity. Exploration does not pause aging, and aging does not wait for exploration to conclude. Within this gentle but unyielding framework, lifespan emerges as a boundary that technology cannot easily soften. Extending life, modestly does not erase the fundamental mismatch between human timescales and cosmic distances. Even if lives were stretched longer, the proportion of that life consumed by travel would still grow heavy. The question is not whether humans could survive long enough to reach distant places, but how much of being human remains intact when so much of life is spent in transit. As time flows steadily onward, it quietly shapes the reach of our journeys, reminding us that exploration unfolds not only through space, but through the fragile, irreversible passage of a human life. As human lifespans quietly impose their limits, time itself begins to behave in subtler ways, no longer flowing as a single shared river for everyone involved in a journey. Early in the last century, careful thought and observation revealed something deeply unintuitive yet gently precise, that motion changes the pace at which time unfolds. This was not discovered through drama or speculation, but through patient reasoning that treated time as something woven together with space, flexible rather than absolute. In this view, clocks are not universal metronomes ticking in perfect agreement. They respond to motion, slipping slightly out of sync when carried along different paths through the universe. Time becomes personal, shaped by the journey taken rather than imposed from above. At everyday speeds, this effect hides beneath perception, far too small to notice. But as velocity increases, the difference becomes measurable, then undeniable. A clock carried aboard a fast moving spacecraft will tick more slowly than one left behind on Earth, not because it is broken or delayed, but because time itself is stretching for the traveler. Seconds lengthen gently, imperceptibly from within, while the outside world ages just a little faster. From the perspective of those on board, everything feels normal. Heartbeats remain steady. Thoughts flow at their usual pace. It is only when paths diverge and reunite, when clocks are compared again, that the difference reveals itself, etched quietly into elapsed moments. This phenomenon offers a strange kind of comfort. It suggests that motion can soften the passage of time for those who travel far and fast. A journey measured in decades for distant observers might consume slightly less experienced time for the traveler. In principle, this could ease the burden of long voyages, allowing explorers to arrive having aged less than those they left behind. The universe, in this sense, appears to offer a small concession to ambition, gently folding time around those who move swiftly enough. Yet this help arrives slowly and at great cost. Time dilation becomes significant only at speeds approaching those of light, far beyond what chemical rockets or even speculative near-future technologies can provide. The energy required to reach such velocities rises steeply, entangled with the same mass and fuel constraints already shaping every journey. For modest speeds, the effect exists but remains slight, shaving off moments or years where centuries would be needed to truly transform the equation. The body, meanwhile, continues to age, though a little more slowly, still vulnerable to the accumulated stresses of time spent away from Earth. The gift is real, but it is small, and it arrives hand in hand with new challenges. More importantly, time dilation does not shorten distance. Space itself remains unchanged, vast and unyielding. The stars do not draw closer simply because time flows differently aboard a moving ship. From the traveler's perspective, the journey still unfolds across immense stretches of emptiness, one moment following another without visual acceleration. Arrival is not brought forward in the lived experience so much as the outside world recedes more quickly. Loved ones age faster, civilizations change more rapidly. The gap between the traveler and their origin widens, not just in space, but in history. In this way, time dilation shifts the nature of separation rather than removing it. It deepens the asymmetry between those who go and those who stay. The traveler may endure slightly less aging, but returns, if return is even possible, to a world that has moved on without them. The clock has not been stopped, only tilted, favoring one path while stretching the other. Distance remains distance, indifferent to how time is experienced along the way. As a solution to the fundamental challenge of space travel, time dilation therefore remains partial and incomplete. It does not allow humans to casually cross interstellar gulfs or erase the deep timescales separating stars. It offers no shortcut through the enormous architecture of the universe. Instead, it reveals something more subtle, that time itself is a participant in the journey, bending gently but refusing to break. Motion can reshape how long a voyage feels, but not how far it truly goes. In accepting this, the universe again makes its quiet terms clear, allowing a small easing of the burden while leaving the greater structure firmly in place. As time stretches and bends along a journey, another invisible presence comes quietly into view, one that cannot be seen through a window or felt through touch, yet passes through bodies as easily as light through glass. Radiation fills space not as a sudden threat, but as a constant background, a quiet rain of energy that never truly stops. Some of it streams outward from the sun, carried by eruptions and winds that sweep through the solar system. Other portions arrive from far beyond, fragments of ancient explosions and distant stars, moving at extraordinary speeds, indifferent to planets, ships, or flesh. In deep space, there is no place to step aside and let it pass. It simply arrives, particle by particle, year after year. Earth has always stood between its life and this steady exposure. The planet's magnetic field curves radiation away like a vast, unseen shield, guiding dangerous particles around rather than through the surface. Above the atmosphere, layers of air absorb and scatter what remains, breaking energetic impacts into gentler interactions before they reach the ground. Life evolved beneath this protection, shaped by filtered sunlight and softened cosmic noise. Cells learn to divide, repair, and persist under these conditions, never needing to contend with the full force of space's energetic environment. Leaving Earth means leaving this quiet guardianship behind. Beyond that shelter, radiation no longer arrives in moderated doses. It moves freely through spacecraft hulls and human tissue, interacting at the smallest scales of matter. When energetic particles strike cells, they can damage the delicate structures that guide growth and repair. DNA, which carries the quiet instructions for every cell, can be bent, broken, or altered in subtle ways. The body is not helpless. It has mechanisms to mend many of these injuries, stitching strands back together and correcting errors when it can. Over short periods, this balance holds. Over long durations, especially measured in years or decades, the accumulation becomes harder to ignore. Prolonged exposure does not announce itself dramatically. There is no immediate pain, no clear moment when harm begins. Instead, risk rises slowly, like a tide that creeps higher with each passing season. The probability of cancers increases. The immune system may weaken. Tissues that renew themselves frequently, such as skin and blood, face repeated challenges that slowly erode resilience. Even the nervous system, sheltered deep within the body, is not entirely spared. These effects are not guaranteed outcomes, but increasing possibilities. Statistical shadows that grow darker the longer a journey lasts. It is tempting to imagine shielding as a straightforward answer, simply placing enough material between the traveler and space. In practice, this solution reveals its own limits. Effective shielding requires mass, and mass must be lifted, accelerated, and carried across vast distances. Thick layers of metal can block some radiation, but they cannot stop all of it. High energy cosmic rays are especially difficult, capable of penetrating substantial barriers and generating secondary particles when they collide with shielding itself. In some cases, adding more material can even create additional radiation inside the ship, transforming protection into a source of new exposure. Water, polymers, and other lighter materials offer partial improvement, slowing particles without producing as many harmful byproducts. Even so, the scale required to fully recreate Earth's natural defenses quickly becomes impractical. A spacecraft robust enough to completely shelter its occupants would be heavy beyond reason, its mass multiplying fuel demands and complicating every aspect of travel. Once again, constraints overlap, each one tightening the space of what remains feasible. This is why radiation becomes a slow, persistent companion on any long mission. It does not forbid travel outright, but it quietly limits duration. Short voyages remain manageable, their risks contained within tolerable bounds. As journeys lengthen, those bounds blur. Time spent in transit becomes time spent accumulating microscopic damage, most of it invisible until its effects surface much later. The challenge is not dramatic survival, but long-term health, the ability to arrive not merely alive, but whole. Radiation reminds us that space is not empty in the way silence suggests. It is active, energetic, and ancient, shaped by processes unfolding long before humans existed. Earth learned how to cradle life within this environment by standing between it and the stars. When humans leave that cradle, they carry ingenuity and caution with them, but they cannot carry the planet itself. The farther and longer they travel, the more they move within a cosmic weather system that does not recognize biology as something to be preserved. In that quiet exposure, radiation becomes another gentle but firm boundary, one that shapes how far human presence can be sustained beyond the world that made it possible. As radiation quietly alters life at the smallest scales, gravity reveals its influence through absence rather than force. On Earth, gravity is a constant presence, so familiar it disappears from awareness, shaping every movement, every heartbeat, every silent adjustment the body makes without permission or notice. Muscles maintain tension simply by existing. Bones stay dense because they are asked, every moment, to bear weight. Blood flows downward and upward in patterns the cardiovascular system has refined over millions of years. When gravity weakens or vanishes, this ancient conversation between body and planet begins to unravel. In orbit or deep space, muscles no longer work to hold posture or lift weight. They relax, then soften, then shrink. Bone tissue, no longer stressed, begins to thin, releasing minerals back into the bloodstream as if the skeleton itself is slowly deciding it is no longer needed. This change is not sudden or dramatic. It arrives quietly, week by week, month by month, until strength that once felt permanent becomes something that must be actively defended through constant exercise and careful monitoring. The heart and blood vessels respond just as subtly. Without gravity pulling fluids downward, blood redistributes toward the chest and head, creating the sensation of fullness. Astronauts often describe early in flight. Over time, the body adapts by reducing total blood volume, assuming it no longer needs to work as hard to push fluid upward. The heart itself begins to change, growing slightly smaller and less forceful, efficient for weightlessness, but poorly prepared for return to gravity. Standing again on a planetary surface can feel overwhelming as blood struggles to flow correctly, leading to dizziness or fainting until systems relearn what Earth demands of them. These adaptations are not failures. They are signs of a body doing exactly what evolution trained it to do, optimizing for present conditions rather than future ones. The problem is not adaptation itself, but the context in which it occurs. Beyond muscles and circulation, gravity's absence reaches into more delicate systems. The eyes, shaped by pressure gradients and fluid balance, can change subtly over long periods, altering vision in ways that may not fully reverse. Inside the skull, shifts in fluid can gently press against structures never meant to bear that load, affecting sight and sensation. The nervous system, too, must reinterpret its signals. Balance, orientation, and movement all rely on gravity as a reference. In its absence, the brain rewires itself, learning new rules for motion while letting old ones fade. This flexibility is remarkable, but it carries a cost. Relearning gravity after long exposure to weightlessness is not instant. It requires time, effort, and patience, and some changes may linger far longer than the journey itself. It is tempting to imagine artificial gravity as an elegant solution, a way to bring Earth along on the voyage. In stories and films, rotating space stations spin gently, creating a familiar downward pull where people walk normally and pour drinks that fall neatly into cups. The reality is more demanding. Creating artificial gravity requires rotation, and rotation introduces new forces that the body must interpret. Spin too slowly, and gravity becomes weak or uneven. Spin too quickly, and motion sickness, disorientation, and strain emerge. A structure large enough to spin gently while producing Earth-like gravity would need to be immense, far larger than anything yet built or launched. Its mass would ripple outward into every other constraint: fuel, structural integrity, energy demands, and maintenance, each one tightening the web of difficulty. Even if such a system were built, gravity would not be perfectly uniform. Subtle differences would arise between head and feet, between inner and outer sections, creating environments similar to none humans evolved within. The body might adapt again, reshaping itself for this compromised world, only to face further challenges upon arrival or return. Artificial gravity, like shielding and fuel, offers help without absolution. It eases some burdens while introducing others, shifting problems rather than erasing them. Through all of this, gravity reminds us that the human body is not a general purpose vessel. It is a product of Earth, tuned finely to one world's mass, one world's pull. When that pull weakens or changes, the body responds honestly, reshaping itself to match its surroundings without regard for mission goals or cosmic distances. Long journeys, therefore, become negotiations between biology and environment, with gravity standing quietly at the center of the discussion. It does not forbid travel, but it ensures that travel will always change the traveler in ways no spacecraft design can fully prevent, carrying Earth's influence within the body, even as the planet itself grows distant. As gravity reshapes the body and quiet forces work their way through bone and blood, another influence settles in more gently, yet just as persistently. Isolation does not arrive as a sudden event. It unfolds slowly, through repetition and enclosure, through days that look like the ones before them, and weeks that blur at the edges. The human brain evolved within a world dense with signals, voices, shifting landscapes, and unpredictable social rhythms. In isolation, many of those signals fall away. The environment becomes stable to the point of stillness, and the nervous system, so finely tuned to change, begins to recalibrate itself in ways that are not always helpful. Attention drifts. Memory softens at the margins. Time, already stretched by distance, begins to lose its familiar texture, flowing unevenly through long periods of sameness. This is not a failure of will or character, it is a biological response. The brain measures reality partly through variation. When variation fades, the mind fills gaps as best it can, sometimes replaying memories with unusual intensity, sometimes turning inward in ways that magnify small concerns. Sleep patterns can slip, untethered from natural light and daily social cues. Dreams become vivid or fragmented. Motivation fluctuates, not because purpose is gone, but because the mechanisms that reinforce purpose have thinned. Over long periods, this quiet reshaping can alter mood, perception, and emotional balance, even in individuals carefully selected and trained for endurance. Earth has offered previews of this experience for decades. Submarines slip beneath the ocean for months at a time, sealed worlds of machinery and routine, where crews adapt to narrow spaces and delayed contact with the surface. Research stations in Antarctica sit isolated at the edge of the world, where winter cuts off travel entirely, and a small group of people shares the same faces, the same corridors, and the same silence for long stretches. Space stations orbit overhead, carrying humans who circle the planet again and again while remaining physically separated from it. In each setting, similar patterns emerge. Structure becomes essential. Rituals matter. Small disruptions can feel larger than they should. Cohesion must be actively maintained, not assumed. These lessons reveal something subtle. Isolation does not act alone. It weaves itself into every other challenge. Physical strain becomes harder to manage when emotional reserves thin. Fatigue deepens when novelty fades. Minor discomforts grow heavier without the relief of fresh surroundings or spontaneous connection. The body and mind do not experience stress as separate categories. They blend. A weakened muscle feels more burdensome when motivation wanes. A disrupted sleep cycle amplifies pain and slows healing. Radiation exposure, bone loss, cardiovascular changes all carry greater weight when the brain is already working harder to maintain balance. Distance intensifies this effect in ways that are easy to underestimate. As communication delays lengthen, interaction with Earth shifts from conversation to correspondence. Responses arrive out of sync with emotion, comfort delayed beyond the moment when it would have mattered most. Shared time dissolves. Events on Earth continue without the traveler, unfolding at a pace that feels detached and unreal. Over years, this separation can produce a gentle sense of dislocation, not dramatic loneliness, but a persistent awareness of being out of phase with the rest of humanity. The farther the journey extends, the more complete this separation becomes. Within this environment, the brain adapts again, learning to conserve emotional energy and narrow focus. This adaptation allows survival, but it also changes experience. Exploration becomes inward as much as outward. Identity shifts, shaped by the confined world of the ship and the limited social sphere it contains. Returning to broader human environments, if return happens at all, requires another adaptation, another slow recalibration to noise, diversity, and constant social motion. Isolation, then, is not merely the absence of company. It is an active condition that shapes biology, psychology, and the relationship between them. It does not forbid long journeys, but it alters them profoundly. The farther humans travel from Earth, the more they carry not just the planet's physical influence within their bodies, but the imprint of its social and sensory richness within their minds. In the deep quiet of space, isolation becomes a steady companion, amplifying other risks not through force, but through absence, reminding us that human beings are not only creatures of gravity and flesh, but of connection, variation, and shared time beneath a living sky. As isolation deepens through physical separation, communication itself begins to thin and stretch, not through failure or malfunction, but through a rule woven into the structure of the universe. Light moves as fast as it can move, and nothing carries information faster than light. Every message sent across space must ride that limit, traveling patiently outward at a fixed pace, indifferent to urgency or emotion. Close to Earth, this delay is barely noticeable, a soft pause between question and response. As distance grows, the pause lengthens, minutes appear, then hours. The simple act of speaking becomes a process rather than an exchange, unfolding across time rather than within it. Words no longer meet one another in the moment. They cross in silence, passing each other somewhere in the dark. When communication slips beyond real time, conversation changes its nature. There is no back and forth rhythm, no shared breath between sentences, no immediate reassurance carried by tone and timing. Messages must be composed carefully, knowing that clarification will not arrive quickly. Emotion lags behind experience. A moment of joy may be described long after it has faded. A moment of fear may echo into an already resolved calm. By the time a response returns, the sender has moved on, altered by hours or days of living in between. Dialogue turns into correspondence, closer to letters carried across oceans than to voices across a room. As delays extend further, the sense of shared time dissolves. Earth continues its daily cycles, its celebrations and losses unfolding on schedule, while the traveler exists on a different temporal island. News arrives out of sequence with emotion, and participation becomes symbolic rather than active. Decisions must be made alone, without the comfort of immediate counsel. Even encouragement arrives too late to soften the moments when it would have mattered most. The ship becomes its own small world, sealed not only by distance, but by time itself. At extreme distances, isolation becomes complete. Communication still exists, but it no longer feels interactive. Messages are records of the past rather than bridges to the present. The traveler knows that Earth is there, that voices still speak and listen, but the delay transforms connection into something abstract. Support becomes a memory of connection rather than an experience of it. The wider human world fades into an idea, carried forward by habit and imagination rather than lived exchange. Silence fills the gaps, not as emptiness, but as duration. The emotional cost of this silence accumulates quietly. Humans are shaped by immediate social feedback, by the subtle confirmations that presence provides. When those confirmations vanish, the mind must work harder to sustain its sense of belonging. Confidence becomes internal rather than shared. Doubt echoes longer. Moments that would have been softened by laughter or reassurance linger unresolved. Over time, the absence of real-time contact can make even strong emotional bonds feel distant, not broken, but stretched thin across the gulf of delayed response. This silence also alters how events are experienced. Triumphs become private, grief becomes solitary. There is no one to witness moments as they unfold, no shared glance that says this mattered right now. Everything must be translated into memory before it can be shared, flattening emotion into description. The ship's inhabitants live slightly ahead of their words, always waiting for language to catch up with life. Communication delay does not prohibit exploration, but it changes its emotional texture. It ensures that no matter how capable technology becomes, human presence far from Earth will carry an element of solitude that cannot be engineered away. The speed of light quietly defines the outer boundary of shared experience, reminding travelers that connection depends not only on signal strength, but on timing. As distance grows, conversation yields to reflection, and the comforting immediacy of human contact is replaced by patience and inner resolve. In this stretched silence, humanity's reach is measured not only in kilometers, but in how much separation the human heart can quietly hold. Communication continues, messages still flow, but the loss of real time contact reshapes the journey into something slower and more inward. The universe does not cut the line completely, it simply lengthens it until connection becomes an echo, faint but persistent, traveling faithfully through the dark, long after the moment that gave it meaning has passed. As communication thins into delay and silence becomes a steady companion, the journey continues outward, not toward a destination marked by scenery, but toward a boundary defined by influence. Far beyond the familiar paths of planets and their slow arcs around the sun, there exists a region where the solar presence weakens, where its touch no longer shapes space as confidently as it once did. The sun does not end suddenly. Its authority fades gradually, carried outward by a continual flow of charged particles and magnetic fields that expand like an invisible breath into the surrounding darkness. This extended domain forms a vast, rounded bubble around the solar system, a place sculpted not by gravity alone, but by pressure and motion, a quiet frontier where the familiar gives way to something older and less shaped by our star. Within this boundary, known gently through metaphor rather than sight, the solar wind slows and bends. The outward rush of particles meets resistance from the interstellar medium, the thin but persistent matter drifting between stars. Here, motion becomes hesitant, forces balance. The sun's influence thins until it can no longer push the surrounding space aside. Crossing this region is not like stepping over a line. It is more like watching a current gradually lose strength until it can no longer carry you. Beyond this point lies interstellar space, a realm not owned by any single star, where conditions are shaped by distant supernovae, ancient radiation, and the slow chemistry of the galaxy itself. Humanity has never followed this path in person, but small, patient messengers have. Long ago, slender spacecraft were sent outward with no expectation of return, carrying instruments, records, and a quiet intention to keep going. Decades passed as they moved through the outer solar system, past planets that themselves felt remote, into regions where sunlight became faint and communications stretched into long waits. These probes continued, year after year, coasting through silence, until at last they began to sense the thinning of the sun's reach. Their measurements shifted subtly, then decisively. The signature of solar particles waned. New energies appeared. Without ceremony, they had entered interstellar space. What these journeys revealed most clearly was not a dramatic crossing, but the sheer scale of distance involved. Reaching the sun's outer boundary took decades at speeds far beyond anything humans have endured, and even then, the destination remained conceptually close on a galactic map. The time required to approach this edge measured itself not in missions or careers, but in generations of scientists who began the work and never saw its quiet culmination. Distance here is not something overcome through intensity or effort. It is something waded through, patiently and without interruption. Even this far from the sun, the universe does not feel empty. The environment changes, but it does not simplify. Magnetic fields twist, particles drift, space remains active, dynamic, and ancient. The idea that this boundary represents an edge in any absolute sense gently dissolves. It is an edge only relative to us, marking where the solar system's identity becomes indistinct. Beyond it, the galaxy continues with the same patience it always has, filled with regions more distant by orders of magnitude, waiting far beyond the reach of even these tireless machines. The distance to this boundary reshapes expectations in a subtle but lasting way. If leaving the solar system requires decades at extraordinary speeds, then every destination beyond must be considered with new humility. The gap between stars, once imagined as the next logical step, reveals itself as a far greater commitment than intuition suggests. The solar system, once thought small, becomes a vast homeland when viewed from its outermost reaches. Its planets feel less like stepping stones and more like distant memories clustered near a single warmth. In drifting toward the sun's fading influence, the story of exploration slows to a near stillness. The lesson offered is not one of defeat, but of scale. Even the nearest boundary between stellar neighborhoods lies far beyond human presence, reached only by machines that do nothing but continue. This region, distant yet still connected to the sun by tenuous threads, reminds us that the architecture of space is built on expanses that resist compression. The edge of the solar system is not a threshold easily crossed. It is a long, patient journey that quietly teaches how far from Earth even the familiar has always been. Beyond the sun's fading influence, the darkness does not open into a clean, untouched void. Interstellar space carries a quiet texture of its own, subtle but persistent, shaped by material spread thinly across immense volumes. Dust grains, gas atoms, stray ions, and roaming radiation drift between the stars, remnants of ancient explosions and slow stellar winds that have been moving long before the solar system took shape. From a distance, this space appears empty because its contents are so widely dispersed, but emptiness in space is a matter of density, not absence. Even here, matter exists, patient and indifferent, waiting across distances that stretch light into years. At human scales, this sparse material feels harmless. A single atom passing through a spacecraft seems insignificant, yet speed transforms insignificance into consequence. When a vessel moves at a substantial fraction of cosmic velocities, even tiny particles carry enormous energy. A grain of dust, no larger than smoke, becomes a projectile. The collision does not need mass in the familiar sense. Motion supplies what mass lacks. Energy concentrates into a point of contact, releasing force capable of puncturing materials, eroding surfaces, and generating secondary radiation within protective layers. What drifts gently through stillness becomes destructive when met at speed. This is one of the quiet paradoxes of deep space travel. The faster one moves, the more dangerous the emptiness becomes. At interstellar velocities, collisions do not announce themselves as impacts in the traditional sense. They are sudden transfers of energy, brief and violent at the microscopic level, accumulating over time into measurable wear. Shields must be designed not only to block radiation, but to absorb repeated strikes from matter too small to see or predict. Over long journeys, erosion becomes inevitable, shaving away surfaces molecule by molecule, altering structures that cannot be easily repaired. Gas, too, plays a subtle role. Individual atoms are harmless alone, but over distances measured in light years, their cumulative effect grows. Passing through tenuous clouds, a spacecraft encounters regions where particle density rises just enough to matter. Friction, in the traditional sense, does not appear, but interactions increase. Radiation levels shift, electrical charges build and dissipate in unfamiliar ways. Navigation becomes more complex as the environment refuses to remain uniform. The ship must endure not just travel, but continual interaction with a medium that never fully disappears. Radiation between stars also carries a different character. Freed from the dominance of any single star, high energy particles roam widely, produced by distant supernovae and violent cosmic events whose echoes persist for millions of years. These particles arrive with immense energy, crossing galaxies before striking anything at all. In interstellar space, their presence becomes more pronounced. They pass through shielding, interact with atoms, and generate cascades of secondary particles that ripple inward. Over long exposure, this radiation adds to the biological and mechanical toll, already shaping the journey, reinforcing the sense that space, even when sparse, is never passive. The hostility of interstellar space does not come from turbulence or visible threat. It comes from scale and persistence. Hazards arrive slowly, steadily, without drama. Damage accumulates silently. Protective systems must function flawlessly for durations that exceed any previous human experience with machines. Maintenance becomes a concept rather than an activity, since repair opportunities are limited by isolation, delay, and finite resources. Each interaction with the environment, however small, contributes to a gradual narrowing of margins. This reality reframes the idea of traveling between stars. The distance is not simply a gap to be crossed, but an environment to be endured. Interstellar space does not offer corridors of emptiness where speed can increase without consequence. It remains an active participant in the journey, shaping outcomes through countless small interactions that add up over time. Even between stars, the universe asserts its presence through dust, gas, and radiation, reminding travelers that motion always carries cost. In this quiet hostility, the myth of empty space fades entirely. What remains is a vast, low density ocean of matter and energy, one that tolerates passage but never yields completely to it. Travel through such a medium demands patience, resilience, and acceptance of limits that cannot be engineered away. Interstellar space is not a blank canvas waiting for human ambition. It is an ancient environment, indifferent to intent, shaping every journey through its subtle, relentless presence. Beyond the diffuse material between stars, attention naturally settles on the nearest lights themselves, those few suns that share our corner of the galaxy and seem, at first glance, almost reachable. Proxima Centauri sits quietly among them, a small, cool star bound loosely to a brighter pair, visible only through instruments, yet often described as our closest neighbor. In maps of the night sky, these stars appear sprinkled nearby, part of the same local community, their distances written in numbers that feel manageable when compared to the vastness beyond. This sense of closeness is comforting, a suggestion that the leap from one star to another might simply be an extension of the journeys already imagined. But space has trained us by now to be careful with impressions, and proximity in astronomy carries meanings very different from proximity in human life. Measured with the tools of physics, even the nearest stars remain astonishingly far away. The distance between our Sun and Proxima Centauri is counted not in millions or billions of kilometers, but in the time it takes light itself to cross the gap. Light, which has already proven so stubbornly limited in communication, requires years to travel between these 2 points. At the fastest speeds humans have ever achieved, covering this distance would stretch far beyond a single lifetime. It would stretch beyond several. A spacecraft launched today, carrying all the ingenuity and constraint already woven into this story, would continue its quiet flight long after its builders, its crew, and the culture that imagined it had faded into history. This reality reshapes the meaning of travel time. A journey lasting centuries cannot be approached the way shorter missions are. It is not simply longer, it becomes generational. Those who depart would not arrive. Those who arrive would not remember the departure. The journey itself would become the dominant feature of existence, shaping societies born and raised between stars, never having seen Earth except through records and inherited memory. Continuity would be fragile. Purpose would need to survive not just engineering challenges, but the slow drift of culture, language, and values across time spans longer than any human institution has reliably endured. The stars themselves offer no reassurance. Proxima Centauri is smaller and dimmer than our Sun, its light faint even at close cosmic range. Nearby systems share similar modesty, red dwarfs and quiet suns scattered sparsely through space, separated by gulfs far wider than the spaces between planets. There are no dense neighborhoods here, no clusters of destinations waiting just beyond the next threshold. Each star stands largely alone, its domain defined by distance rather than community. Traveling between them resembles crossing an ocean where islands are separated, not by days of sailing, but by lifetimes of uninterrupted motion. The illusion of proximity arises from the way astronomy presents the sky. From Earth, stars appear projected onto a single surface, a dome of light where depth collapses into pattern. Constellations form shapes that feel intimate, familiar, and close, even though their members may lie hundreds of light years apart. Names like nearest star and local neighborhood reinforce this sense, compressing staggering distances into tidy categories the mind can hold. Telescopes sharpen this illusion by bringing faint objects into view, making distant systems seem present, almost touchable. Vision suggests accessibility, while physics quietly insists otherwise. As understanding deepens, the idea of nearby stars transforms. They remain close only by cosmic standards, not human ones. The gap between stars becomes a reminder that the galaxy is built for patience, not passage. Motion through this structure is possible in principle, but not in the way everyday language implies. The distances do not prohibit travel outright, but they redefine it so thoroughly that familiar concepts of journey, return, and arrival begin to dissolve. In this softened light, the nearest stars no longer beckon as destinations waiting just beyond reach. They stand instead as markers of scale, teaching how carefully the universe spaces its suns. They show that even the smallest steps outward from our own star require commitments measured not in effort or bravery, but in time so deep it reshapes what it means to go anywhere at all. As nearby stars recede into distances measured in lifetimes rather than years, one idea quietly returns again and again, not as a promise but as a concession. If a single human life is too brief to cross the gulf between stars, then perhaps many lives could share the task. Generational travel emerges from this line of thought, not as a heroic sprint, but as a long, continuous drifting of humanity itself. In theory, a vessel could depart with one generation, carry their children and grandchildren, and arrive with descendants who never knew Earth except through stories. The ship would no longer be a vehicle in the ordinary sense. It would become a world, closed and self-contained, tasked not only with movement through space, but with sustaining culture, knowledge, and life across centuries of uninterrupted time. The difficulty of this vision lies not in imagination, but in endurance. A multi-generation ship must function as an ecosystem as much as a machine. Food, Water, air, and energy would need to circulate flawlessly, not for years, but for spans longer than most civilizations have lasted on Earth. Small imbalances would not simply inconvenience the crew. Over decades, they would compound, pushing systems slowly toward failure. Maintenance would not be episodic, it would be continuous, passed down through training and memory, dependent on each generation learning skills accurately from the last. Knowledge loss would be as dangerous as mechanical breakdown and far harder to detect before consequences appear. Social structure becomes equally fragile over such timescales. A community born and raised within a vessel did not choose the journey, yet must live entirely within its constraints. Authority, purpose, and shared meaning would need constant renewal. Conflicts that on Earth might dissipate through movement, change, or separation would have nowhere to go. Every disagreement would echo within the same enclosed population, generation after generation. Cultural drift would be inevitable. Values would shift. Language would evolve. The original mission, once vivid, could soften into legend, then abstraction, then irrelevance. Continuity would rely not on technology alone, but on stories, rituals, and shared understanding surviving centuries without distortion. Biology adds another layer of quiet difficulty. A closed population limits genetic diversity. Over time, this narrowing increases vulnerability to disease, reduces resilience, and amplifies the impact of random chance. Careful planning could reduce these risks, but cannot eliminate them entirely. Evolution would not pause simply because the journey demands stability. Natural variation would continue, shaped by the artificial environment of the ship rather than the open ecosystems of Earth. Traits that suit confinement might flourish, while others fade, subtly altering the population in ways no blueprint could fully predict. Ethical questions arise naturally from this situation, though they do not need to be spoken aloud to exert pressure. Children born aboard such a vessel inherit a destiny decided long before their existence. Their world would be defined by walls and corridors, by routines designed for survival rather than exploration. Choice becomes constrained by circumstance. Even if the mission remains intact, the lived experience of those generations differs profoundly from the intention of those who launched the journey. Survival becomes the primary measure of success, yet survival alone does not ensure fulfillment, meaning, or continuity of purpose. Planning can address many known risks, but it cannot plan away time itself. Over centuries, unforeseen events accumulate. Minor failures become turning points. Social fractures, environmental shifts within the ship, or gradual loss of critical expertise could alter the trajectory of the mission without any single moment of catastrophe. The idea that careful design guarantees success grows less convincing as duration expands. History on Earth offers countless examples of societies that began with strong structures and clear intentions, only to fragment or transform in ways no founder could foresee. This fragility does not render generational travel impossible, but it reframes it as something far more uncertain than diagrams suggest. It is not a solution that neatly bypasses distance. It is a transformation of exploration into inheritance. The journey becomes less about reaching a destination and more about maintaining coherence across time, an achievement arguably more demanding than crossing space itself. Survival, in this context, is not a binary outcome. It is a continuous negotiation with entropy, biology, and human nature. As the idea settles, it becomes clear that multi-generation travel does not escape the universe's limits, it internalizes them. The vast distance between stars is not erased, It is absorbed into the fabric of human life aboard the ship, stretching existence across centuries and asking continuity to hold where certainty never can. In this long drift, planning offers structure and hope, but no guarantee, reminding us that carrying humanity forward through space also carries forward all of its complexity, vulnerability, and quiet unpredictability. As generational journeys stretch human presence across centuries, the question of sustenance moves from logistics to existence itself. A closed system must do more than supply food and water. It must remain alive in a balanced way, cycling matter endlessly without erosion, loss, or drift. On Earth, ecosystems achieve this through immense scale, diversity, and constant energy input from the sun. Countless organisms overlap in function, absorbing shocks and smoothing imbalances before they become crises. In a spacecraft or sealed habitat, that margin disappears. Every organism, every process, every exchange of matter must perform reliably within tight limits, year after year, generation after generation. Growing food in such an environment is not simply agriculture moved indoors. Plants must thrive under artificial light, limited space, and carefully regulated conditions. Soil, if used at all, becomes a managed material rather than a living landscape. Microorganisms that quietly maintain fertility must be preserved without allowing unwanted species to gain dominance. Pests and disease, trivial on Earth's open fields, can become devastating in enclosed environments where natural controls are absent. Diversity, which stabilizes ecosystems, must be carefully curated rather than allowed to arise naturally. This curation demands constant knowledge, vigilance, and adjustment, a continuous act of ecological balance carried by human intention alone. Water, equally essential, presents its own quiet difficulties. In closed systems, water cannot be taken for granted as something that returns endlessly through clouds, rivers, and oceans. Every drop must be recovered, purified, and reused. Recycling technologies can reclaim astonishing amounts, but not everything. Trace losses accumulate through leaks, evaporation, and chemical binding. Contaminants build slowly, requiring ever more complex filtration to remove. Over years, then decades, the water system becomes more than infrastructure. It becomes a living archive of every use, every mistake, every adaptation layered atop the last. Managing it demands precision and patience beyond ordinary human timescales. Even when recycling approaches near completeness, limits remain. Matter degrades, materials break down, nutrients become trapped in forms that are difficult to reclaim. Small inefficiencies, harmless over weeks or months, compound over years. A fraction of a percent lost per cycle becomes significant when multiplied thousands of times. On Earth, these losses vanish into vast reservoirs. In a closed system, they shrink the margin of survival with each passing year. There is no outside supply to correct the drift. Humanity has experimented with these ideas in carefully controlled environments on Earth, sealed habitats designed to simulate self-sufficiency. These experiments revealed not catastrophe, but complexity. Small imbalances emerged in unexpected places. Oxygen levels drifted, nutrient cycles behaved differently than predicted. Social stress altered how people interacted with the environment itself, influencing maintenance and attention. What looked stable on paper proved dynamic in reality. These systems did not fail dramatically. They demanded constant intervention, revealing how difficult it is to predict every interaction in an enclosed web of life. Over long journeys, Such systems face an additional challenge. Knowledge must persist. Skills required to manage closed ecosystems are not instinctive. They must be taught, learned, and practiced accurately across generations. A single mistake may not matter. Repeated misunderstandings, gaps in training, or gradual simplification of procedures can introduce vulnerabilities that remain hidden until they reach a tipping point. By the time symptoms appear, correction may already be difficult or impossible. This is how small failures cascade. A minor nutrient imbalance affects crop health. Reduced crop quality strains dietary balance. Health declines subtly. Fatigue increases. Maintenance slips. Systems receive less careful attention. Errors accumulate. None of these steps need be dramatic. The danger lies in their interaction. In closed environments, feedback loops are tight. Changes propagate quickly and return amplified. Stability becomes something actively maintained rather than passively enjoyed. Food and water, then, are not merely supplies to be packed or grown. They are processes that must remain in harmony with human biology and behavior across immense spans of time. Their management becomes a form of long-term caregiving, attentive and continuous, without respite. The success of any extended journey depends less on dramatic breakthroughs than on the quiet persistence of balance, preserved day after day in systems that do not forgive neglect. In these closed worlds, survival is not defined by reaching a destination. It is defined by maintaining equilibrium. The universe offers no assistance in this task. It simply waits. Each generation inherits not only the mission, but the delicate web that sustains it, one that must remain intact long enough for the journey to continue at all. As closed systems demand balance across generations, navigation begins to reveal a different kind of fragility, one rooted not in machinery or biology, but in time itself. On Earth, maps feel stable. Continents shift slowly enough to ignore. Cities hold their names and positions long enough to anchor memory. In space, nothing stays where it was. Stars drift through the galaxy on immense arcs, each following its own path, shaped by gravity accumulated over billions of years. Constellations that appear fixed to the human eye are temporary arrangements, frozen only by the short span of a human lifetime. Over centuries, those patterns loosen. Over millennia, they dissolve entirely. A destination chosen at launch does not wait politely in place. It continues its own long journey, indifferent to who may be trying to follow. This motion is subtle but relentless. A star like Proxima Centauri moves relative to the Sun, carrying its surrounding space along with it. The galaxy itself rotates, sweeping stars around its center like leaves in a slow cosmic current. Even the Sun is not stationary. It drifts through the Milky Way, pulling the solar system along on a path that curves gently but never stops. Navigation across such a landscape is not a matter of pointing and going. It requires prediction layered upon prediction, an understanding not just of where something is now, but where it will be after centuries of uninterrupted motion. The longer the journey, the wider the margin for error becomes. A tiny miscalculation, invisible at first, grows steadily as time passes, nudging a spacecraft farther from its intended path year by year. Aiming across centuries transforms navigation into an act of faith in knowledge preservation. The mathematics guiding the trajectory must remain intelligible long after those who designed it are gone. Instruments must continue to function or be repaired or be replaced with equivalents that still align with the original plan. Reference points must be updated as the sky slowly rearranges itself. The destination must be tracked continually, not assumed. Navigation ceases to be a single decision made at launch and becomes a living process passed from one generation to the next like a careful tradition. Even with constant correction, uncertainty accumulates. Interstellar space is not uniform. Gravitational influences from passing stars, unseen clouds of gas, and subtle interactions with the galactic environment introduce tiny deviations. Each one is small, almost negligible in isolation. Over vast spans of time, they compound. A course that appears true for decades may drift meaningfully over a century. Adjustments consume energy, which is already precious. Choices must be made between conserving resources and maintaining precision, between accepting a looser arrival window and risking complete miss. The idea of a fixed destination begins to soften under this weight. Space reveals itself not as a static stage, but as a moving tapestry. Targets slide, paths curve, even arrival becomes a relative concept. The place one intends to reach may not be where it was imagined by the time the journey nears its end. Navigation shifts from straight lines to evolving relationships, tracking not absolute positions, but motions within motions. It demands a humility toward the scale of the system being crossed, an acceptance that certainty fades as duration grows. In this context, space becomes a moving target in the most literal sense. Reaching another star requires not only endurance and survival, but alignment with a destination that is itself in motion. The challenge is not simply to go far, but to arrive where intended after time has had its say. This transforms exploration into something slower and more tentative than fiction suggests. Progress is measured not by distance covered, but by how well coherence is maintained between intention and reality over centuries of drift. As navigation stretches across immense timescales, it reinforces a recurring lesson: the universe does not stand still to accommodate travelers. It moves according to its own deep rhythms, tracing patterns far older than human ambition. To journey within it is to participate in that motion, adjusting gently, correcting patiently, and accepting that even the act of knowing where one is becomes a long, careful conversation with time itself. As navigation stretches across centuries and destinations drift beneath careful calculations, a deeper motion begins to reveal itself, one that no amount of course correction can outpace. Space itself is not a still backdrop through which stars quietly move. It is active, stretching gently but relentlessly in every direction at once. This expansion does not behave like an explosion racing outward from a center. It acts more like a fabric slowly being pulled wider, carrying everything embedded within it along for the ride. Galaxies are not fleeing through space so much as being carried apart by space growing between them. On small scales, this stretching is invisible. Gravity binds stars into galaxies and galaxies into clusters, holding local neighborhoods together. But beyond those bonds, the expansion takes over, quietly increasing the distance between faraway systems without regard for how fast anything tries to follow. As distances grow, this expansion changes how motion is experienced. Distant galaxies appear to move away faster the farther they already are, not because they accelerate under their own power, but because more space is being added between us and them each moment. Light traveling toward us from those systems must cross an ever-widening gulf, stretching itself thin along the way. Over time, that light reddens, its energy diluted by the expansion it traverses. The universe reveals its motion not through wind or force, but through subtle shifts in color and timing, through the slow dimming of objects whose light has journeyed across ages of stretching space. This has a quiet but profound consequence. There exists a distance beyond which expansion outpaces any attempt at travel. No matter how long one moves or how steadily speed is maintained, some regions recede faster than approach can close the gap. These places are not forbidden by barriers or guarded by violence. They are simply carried away by the universe itself, drifting beyond reach without ever announcing their departure. The idea of unreachable regions emerges not as speculation, but as geometry. Space grows, and growth creates separation that cannot be undone by motion alone. As time passes, more of the universe slips across this threshold. Galaxies that are visible today will, given enough cosmic time, fade from view entirely, their light stretched beyond detectability, their presence erased from future skies. The universe does not become smaller or emptier in truth, but it becomes quieter from any single vantage point. What remains accessible contracts, not because of collapse, but because of expansion's steady influence. The observable portion of the universe becomes a shrinking island of connection within a far larger, unreachable whole. For travelers, this expansion acts as a boundary unlike any encountered before. Fuel limits, lifespans, radiation, and distance all constrain movement within space. But expansion defines the shape of space itself. It establishes horizons that no craft can cross, not even in principle, because the separation is not static. It increases continuously, ensuring that effort never gains ground. This boundary is not aligned with human ambition or scale. It does not care how close a destination seems or how long a journey is planned. It arises from the universe's own history and energy, unfolding independently of any traveler's intent. Within this framework, exploration takes on a quieter tone. The universe allows observation without access, knowledge without presence. Light from unreachable regions still arrives, carrying stories from the deep past, offering insight into epochs no one will ever visit. The act of seeing replaces the act of going. Understanding becomes the furthest form of travel available. Expansion gently separates experience from awareness, allowing minds to range farther than bodies ever could. As space continues to stretch, it sets a limit not marked by distance alone, but by time and motion intertwined. The universe reveals that reach is not infinite, even in imagination. Some places exist only as information, never as destinations. This is not a closing door, but a shaping of possibility. Expansion does not diminish wonder, it reframes it. The cosmos remains vast beyond measure, but human presence moves within a bounded region, defined not by failure or lack of effort, but by the deep, ongoing motion of space itself, unfolding patiently as the story of the universe continues outward, forever carrying more beyond reach than can ever be crossed. As expansion stretches space and quietly redraws the edges of what can be reached, another boundary comes into view, one defined not by motion, but by sight itself. The observable universe is not the entirety of what exists. It is the portion of reality that has had time to reveal itself to us. Light, moving patiently at a fixed pace, carries information across space, but it can only bring news from regions whose signals have managed to arrive since the universe became transparent enough to let light travel freely. Everything beyond that limit remains real, yet unseen, not hidden by darkness, but by time. This boundary is shaped by history. When the universe was young, it was hot and dense, filled with matter and energy so tightly packed that light could not move far before being scattered. As space expanded and cooled, light was finally released, beginning a long outward journey in every direction. That first light still travels today, stretched and softened into faint background radiation that fills the sky. It marks the farthest distance from which any information can currently reach us. The observable universe is therefore not a sphere drawn around Earth in space, but a sphere drawn around the present moment in time. Its size reflects how long the universe has been allowing light to travel, not how far reality extends. Light defines this horizon with quiet authority. No signal, no matter how energetic or clever, can arrive faster. Events occurring beyond that boundary may shine brilliantly, evolve dramatically, or collapse into something new, but their stories cannot yet reach us. The space between us and them expands, carrying their light away as quickly as it moves inward. For those regions, contact is not merely delayed, it is permanently denied. Their existence remains inferred through theory and symmetry rather than witnessed through observation. This introduces a humbling distinction. There is the universe that exists, vast beyond imagination, and the universe that can be observed, bounded by the finite age of time and the constant speed of light. The observable universe grows slowly as time passes, incorporating regions whose light has finally arrived. Yet at the same time, expansion pushes other regions beyond reach, faster than observation can catch up. The horizon shifts, but it never disappears. No matter how long humanity watches, there will always be more beyond sight than within it. These unreachable regions are not empty or incomplete. They likely contain galaxies, stars, and worlds similar to those we can see, shaped by the same laws of physics that operate here. Their separation is not due to difference or hostility. It is a simple consequence of how space and time have unfolded. Reality extends farther than any signal can travel, ensuring that total knowledge remains out of reach, not because of failure, but because of structure. This limit is not technological. It cannot be overcome by better instruments, faster ships, or longer lifespans. It is baked into reality itself. Even a hypothetical observer who could wait indefinitely would still face horizons defined by expansion. The universe does not merely place obstacles in the way of exploration, it constructs boundaries that no amount of persistence can cross, boundaries that exist not at a place, but in the relationship between time, motion, and space. Within this framework, understanding replaces access as the deepest form of exploration. Cosmology becomes the art of learning from what can be seen, measured, and inferred, while accepting that the complete picture will always remain partially hidden. Patterns in the observable universe hint at what lies beyond, allowing scientists to build models that extend past the visible horizon, not as guesses, but as careful extrapolations grounded in observed law. Knowledge advances even as presence remains constrained. The observable universe thus becomes a reminder of scale and humility. It shows that the limits encountered earlier, fuel, biology, distance, and time, are nested within an even larger constraint. Some regions of existence will never be reached, never visited, and never directly known. Their separation is not a tragedy, but a characteristic of a universe that is both generous in what it reveals and firm in what it withholds. As the night sky glows with light that has traveled for billions of years, it carries not only stories of distant places, but evidence of a deeper truth. Reality does not arrange itself to be fully accessible. It allows glimpses, connections, and understanding within bounds that cannot be stretched away. In that acceptance, the observable universe offers its final lesson that limits are not merely barriers to overcome, but features of the cosmos itself, shaping how far sight, knowledge, and presence can ever reach. As the observable universe settles into view with its firm and quiet boundaries, another limit rises beneath every journey and every ambition, one that does not depend on distance or time, but on energy itself. Energy is the currency that allows motion, growth, repair, and persistence. Every light that shines, every star that burns, every living system that maintains its order does so by drawing from available energy and releasing the rest as waste. This is not a flaw in design, but a fundamental pattern woven into how the universe operates. Energy is abundant in some places and scarce in others, but it is never infinite, and it is never extracted without consequence. Finite energy extraction shapes every large scale process. Stars fuse their fuel slowly and steadily, converting mass into light over billions of years. Planets store heat and release it gradually. Living systems borrow energy briefly, organize themselves for a time, and then return that energy in less useful forms. No system, no matter how sophisticated, can take energy from its surroundings without leaving something behind. Each act of use slightly degrades what remains, not through damage, but through redistribution. Energy spreads, becoming less concentrated, harder to gather, more difficult to put back to work. This is where efficiency reveals its quiet ceiling. Machines can be improved, designs refined, losses reduced, but never fully eliminated. There is always some energy that slips away, as heat, as vibration, as motion that serves no purpose. These losses are not the result of poor engineering. They arise from the basic structure of reality. Energy naturally flows from concentrated states to dispersed ones. Reversing that flow requires effort, and that effort itself consumes energy, producing further dispersion. Chasing perfect efficiency becomes an endless loop, one that approaches an ideal it can never reach. Thermodynamics describes this behavior with calm clarity. It does not speak of failure or limitation, but of direction. Systems tend toward disorder, not because order is impossible, but because maintaining order demands continuous input. Life, stars, civilizations, and machines all stand briefly against this tendency by drawing energy inward and organizing it. Over time, sustaining that organization becomes harder as usable energy thins. Waste heat accumulates, gradients flatten. What once flowed easily now requires more effort to move. This pattern applies equally to cosmic scales and human ones. Galaxies shine brightly in their youth, rich with gas and active star formation. Over time, fuel is consumed, stars age, and brightness softens. Civilizations grow by tapping concentrated energy sources, first easily available ones, then increasingly complex and diffuse ones. Each transition yields less return for more effort. Growth does not halt suddenly, it slows. Momentum carries systems forward even as the slope steepens beneath them. In this sense, the universe imposes a gentle moderation on expansion of all kinds. It does not forbid growth, but it resists unending acceleration. Energy that can perform work becomes harder to find and harder to harness as systems mature. This is true whether the system is a star cluster, a biosphere, or a technological society reaching outward into space. The farther one pushes, the more carefully energy must be used, and the more visible the limits become. For long journeys, these constraints shape every possibility, sustaining motion, shielding life, recycling matter, correcting course, and maintaining knowledge all demand energy. As time stretches and distances widen, The energy budget becomes not just a practical concern, but a defining feature of what remains feasible. Even if every other challenge were softened, energy would still set the pace, not through sudden shortage, but through gradual thinning of margins. This is why growth slows everywhere, not because ambition fades, but because each step forward costs more than the last. The universe does not punish effort, it simply asks for balance. Expansion that ignores energy limits eventually meets resistance, not as a wall, but as diminishing returns. The glow of activity dims, systems stabilize or decline into quieter states. Change continues, but at a gentler tempo. Within this understanding, the universe feels less like a battlefield against limits and more like a landscape shaped by them. Energy flows determine what is possible and for how long. They guide stars through their lives, shape galaxies across time, and set the outer rhythm of exploration itself. As humanity looks outward, these principles follow, not as obstacles, but as companions, reminding us that every journey unfolds within a cosmos where energy is precious, efficiency is bounded, and growth, everywhere and always, learns when to slow. As energy reveals its limits and growth learns when to slow, another principle rises quietly beneath everything that endures. Entropy is not an enemy or a force that attacks from outside. It is a tendency woven into how change unfolds, a gentle but persistent drift toward disorder whenever energy flows and time passes. Systems decay not because they are flawed, but because maintaining structure requires constant effort. Left alone, arrangements unravel, patterns soften, differences even out. This happens in stars as they burn their fuel, in machines as parts wear against one another, and in living systems as cells age and repair becomes less precise. Order is never static. It is borrowed, held briefly in place through work, then released again. Travel through space intensifies this process in subtle ways. Every journey is an act of sustained organization imposed on an environment that does not naturally support it. A spacecraft must keep temperature, pressure, chemistry, and structure within narrow bands while moving through a cosmos that trends toward equilibrium. Energy is constantly spent to hold that balance, running pumps, correcting trajectories, recycling air, filtering water, shielding radiation, and preserving life itself. Each action produces waste heat, microscopic wear, and small deviations that must be corrected later with yet more energy. Nothing breaks all at once. Instead, countless tiny imperfections accumulate, each one insignificant alone, together forming a steady erosion of margin. Distance magnifies this effect. The longer a journey lasts, the more time entropy has to work. Materials fatigue, surfaces degrade, seals loosen, electronics drift out of calibration. Even knowledge decays. As memories fade, instructions simplify, and assumptions quietly replace original understanding. On Earth, entropy is managed through repair, replacement, and the vast buffering capacity of open systems. In deep space, those buffers shrink. Replacement parts are limited. Repairs must be improvised. Errors that would be trivial in familiar environments become persistent companions. The universe does not rush this process. It allows it to unfold patiently, without drama or warning. Entropy also shapes biology along the way. Cells constantly fight disorder by repairing damage, maintaining gradients, and preserving structure against thermal noise and radiation. Over time, this effort grows harder. Repair mechanisms lose precision. Accumulated damage alters function. Aging is not a failure of design, but an expression of entropy within living matter. Long journeys extend this struggle, asking bodies to maintain coherence under conditions far from those they evolved within. The cost is not always visible at first. It appears gradually, through reduced resilience and slower recovery, subtle signs that the balance between order and disorder is shifting. No technology escapes this quiet drain. Even the most advanced systems must obey the same rules. Perfect maintenance is not possible, only approximated. Each cycle of correction leaves residue, whether as heat, waste, or complexity added to control systems. Over extended durations, complexity itself becomes a form of entropy, increasing the number of ways something can go wrong. Designing systems robust enough to last decades is difficult. Designing ones that remain stable across centuries is something else entirely. Every added safeguard introduces new interactions, new dependencies, and new points of failure that must also be managed. This is how entropy limits long journeys, without ever announcing itself as a barrier. There is no single moment where disorder suddenly wins. Instead, the cost of maintaining order slowly increases until it outweighs available energy, attention, or resources. Travel does not stop because motion becomes impossible, but because sustaining the conditions that allow motion becomes too demanding. The ship continues to drift, but its capacity to support life and purpose thins. Entropy also reshapes goals. Early in a journey, ambition may focus on reaching a destination. As time passes, preserving function takes precedence. Maintenance becomes the primary activity. Exploration turns inward, concerned less with moving farther and more with keeping what already exists from slipping away. This shift is not defeat, it is adaptation to reality. The universe permits order, but only temporarily and only with care. Seen from this perspective, entropy is not hostile, it is simply honest. It reminds every system that nothing is permanent, that effort must be renewed continuously, and that endurance is always conditional. In the quiet drain it imposes, entropy teaches restraint and humility. It ensures that no journey can be endless, no structure unchanging, no victory final. As travelers move outward, carrying fragile pockets of order with them, they do so against a background that gently, patiently, and without exception pulls everything toward rest. As the universe cools and travel grows more demanding, a quiet distinction sharpens, one that has been present all along but becomes clearer with distance and time. Exploration and reach are not the same thing. Exploration is the act of learning, of seeing, measuring, and understanding. Reach is the act of arriving, of placing a body somewhere and enduring the conditions found there. The night sky invites exploration easily. Light travels freely across vast distances, carrying information without asking permission or payment. Reach, by contrast, demands everything. It asks for energy, protection, time, and survival, all at once. As space stretches outward and constraints accumulate, exploration continues to expand even as physical reach begins to slow. Seeing has always outpaced visiting. Long before humans understood the structure of the solar system, the stars had already told their stories through light. Telescopes extend this conversation, capturing photons that left their sources long before Earth had names or borders. These observations do not move bodies through space, but they move understanding through time. A distant planet's atmosphere can be studied without ever approaching it. A galaxy's history can be reconstructed from patterns etched into faint light. In this way, exploration unfolds without footprints, without exposure to radiation or isolation, without the fragile needs of biology. Knowledge travels where flesh cannot. Machines amplify this difference. Probes do not require air, warmth, or comfort. They do not age in the way bodies do, nor do they carry the psychological weight of isolation. A machine can coast silently for decades, indifferent to boredom and loss, patient beyond human tolerance. It can endure radiation that would slowly unravel living tissue. It can accept one-way journeys without sorrow or regret. Freed from the need to return, machines extend humanity's senses far beyond its physical presence, touching places that would consume human life long before arrival. This is why machines go farther than bodies, not because they are braver or more capable, but because they ask less of the universe. Their requirements are simpler, their vulnerabilities fewer. When systems fail, no life is lost. When communication lags or ends entirely, nothing suffers. A probe drifting beyond contact does not experience abandonment. It simply continues until energy fades or components wear away. Its success lies in the data already sent home, in the expansion of understanding it made possible along the way. Indirect exploration reshapes what it means to explore it all. Rather than measuring achievement by presence, it measures it by insight. Mapping surfaces from orbit, sampling atmospheres remotely, listening to cosmic signals from afar. All of these acts deepen connection without demanding proximity. They allow humanity to participate in a universe that would otherwise remain unreachable. Indirect exploration does not conquer space. It listens to it. It accepts separation while still forming relationship. This approach aligns naturally with the limits revealed earlier. As energy becomes scarcer, entropy grows, and distances remain vast, sending people everywhere becomes less reasonable. Sending instruments remains viable far longer. Machines can be optimized for narrow tasks, built to endure specific conditions, and allowed to fail without tragedy. They can be multiplied and distributed, creating a wide net of observation rather than a single fragile presence. Through them, reach is replaced with influence, and travel becomes a matter of perception rather than displacement. The distinction also carries ethical weight. Choosing machines over people acknowledges the cost of sending life into environments that do not support it. It recognizes that curiosity does not require sacrifice beyond necessity. Exploration becomes an extension of care rather than defiance. It respects the boundaries the universe sets while still engaging deeply with what lies beyond them. As this understanding settles, the story of space exploration becomes quieter, but no less profound. Humanity's reach may remain close to home, anchored near Earth and its immediate neighborhood. Exploration, however, ranges freely, limited only by light, time, and imagination disciplined by science. Through indirect means, the universe remains open to study even as it resists physical presence. Seeing replaces visiting. Understanding replaces occupation. In this balance, exploration continues without demanding what cannot be sustained. It becomes a practice of patience and humility, gathering knowledge without insisting on arrival. The universe allows this exchange generously, offering its signals freely while guarding its distances. In learning the difference between exploration and reach, humanity does not shrink its ambition. It refines it, aligning curiosity with the quiet truths of a cosmos that can be known far more easily than it can ever be crossed. As the universe cools and travel grows more demanding, a quiet distinction sharpens, one that has been present all along but becomes clearer with distance and time. Exploration and reach are not the same thing. Exploration is the act of learning, of seeing, measuring, and understanding. Reach is the act of arriving, of placing a body somewhere and enduring the conditions found there. The night sky invites exploration easily. Light travels freely across vast distances, carrying information without asking permission or payment. Reach, by contrast, demands everything. It asks for energy, protection, time, and survival, all at once. As space stretches outward and constraints accumulate, exploration continues to expand even as physical reach begins to slow. Seeing has always outpaced visiting. Long before humans understood the structure of the solar system, the stars had already told their stories through light. Telescopes extend this conversation, capturing photons that left their sources long before Earth had names or borders. These observations do not move bodies through space, but they move understanding through time. A distant planet's atmosphere can be studied without ever approaching it. A galaxy's history can be reconstructed from patterns etched into faint light. In this way, exploration unfolds without footprints, without exposure to radiation or isolation, without the fragile needs of biology. Knowledge travels where flesh cannot. Machines amplify this difference. Probes do not require air, warmth, or comfort. They do not age in the way bodies do, nor do they carry the psychological weight of isolation. A machine can coast silently for decades, indifferent to boredom and loss, patient beyond human tolerance. It can endure radiation that would slowly unravel living tissue. It can accept one-way journeys without sorrow or regret. Freed from the need to return, machines extend humanity's senses far beyond its physical presence, touching places that would consume human life long before arrival. This is why machines go farther than bodies, not because they are braver or more capable, but because they ask less of the universe. Their requirements are simpler, their vulnerabilities fewer. When systems fail, no life is lost. When communication lags or ends entirely, nothing suffers. A probe drifting beyond contact does not experience abandonment. It simply continues until energy fades or components wear away. Its success lies in the data already sent home, in the expansion of understanding it made possible along the way. Indirect exploration reshapes what it means to explore it all. Rather than measuring achievement by presence, it measures it by insight. Mapping surfaces from orbit, sampling atmospheres remotely, listening to cosmic signals from afar. All of these acts deepen connection without demanding proximity. They allow humanity to participate in a universe that would otherwise remain unreachable. Indirect exploration does not conquer space. It listens to it. It accepts separation while still forming relationship. This approach aligns naturally with the limits revealed earlier. As energy becomes scarcer, entropy grows, and distances remain vast, sending people everywhere becomes less reasonable. Sending instruments remains viable far longer. Machines can be optimized for narrow tasks, built to endure specific conditions, and allowed to fail without tragedy. They can be multiplied and distributed, creating a wide net of observation rather than a single fragile presence. Through them, reach is replaced with influence, and travel becomes a matter of perception rather than displacement. The distinction also carries ethical weight. Choosing machines over people acknowledges the cost of sending life into environments that do not support it. It recognizes that curiosity does not require sacrifice beyond necessity. Exploration becomes an extension of care rather than defiance. It respects the boundaries the universe sets while still engaging deeply with what lies beyond them. As this understanding settles, the story of space exploration becomes quieter, but no less profound. Humanity's reach may remain close to home, anchored near Earth and its immediate neighborhood. Exploration, however, ranges freely, limited only by light, time, and imagination disciplined by science. Through indirect means, the universe remains open to study even as it resists physical presence. Seeing replaces visiting, understanding replaces occupation. In this balance, exploration continues without demanding what cannot be sustained. It becomes a practice of patience and humility, gathering knowledge without insisting on arrival. The universe allows this exchange generously, offering its signals freely while guarding its distances. In learning the difference between exploration and reach, humanity does not shrink its ambition. It refines it, aligning curiosity with the quiet truths of a cosmos that can be known far more easily than it can ever be crossed. As exploration finds its way through instruments rather than bodies, the reason for this separation becomes steadily clearer. Humans are not general purpose travelers. Every aspect of the human body carries the imprint of a single world, shaped slowly by gravity, atmosphere, chemistry, and rhythm that have remained stable for immense spans of time. Evolution works through fine tuning rather than reinvention, adjusting existing structures incrementally in response to consistent pressures. The result is a form exquisitely suited to Earth, balanced delicately within a narrow range of conditions. Bones are dense because they evolved under constant weight. Lungs are tuned to air of a particular thickness and composition. Skin expects a certain level of radiation filtered by atmosphere and magnetic field. Even the brain is calibrated to cycles of light and darkness set by a rotating planet. None of these traits are accidents. They are solutions to a specific environment, refined over millions of years of small, persistent change. Adaptation, however, is slow by design. It proceeds through generations, not lifetimes. Useful traits spread only if they improve survival and reproduction under prevailing conditions. Dramatic shifts do not produce rapid improvement. They produce stress, vulnerability, and often extinction. When environments change faster than biology can respond, organisms do not transform smoothly. They disappear. This is why adaptation cannot be summoned on demand. A human cannot gradually adjust to weightlessness or radiation over a lifetime in a way that produces lasting improvement. The body adapts temporarily, often at a cost, but those changes are not passed on in ways that build resilience. Evolution requires stability long enough for selection to work, and space offers none of the consistency that Earth provides. Biological flexibility exists, but it has limits. Humans can tolerate short periods without gravity, limited radiation exposure, altered day lengths, and confined environments. Beyond those ranges, systems begin to fail rather than adapt. Muscles weaken, bones thin, vision distorts, immune function shifts. These are not signs of poor design. They are signs of specialization. The human body did not evolve to be flexible across every possible condition. It evolved to be highly effective within a specific set of constraints, and that effectiveness comes at the expense of versatility. Space sits far outside that evolutionary comfort zone. Its vacuum strips away pressure instantly. Its radiation penetrates deeply. Its temperatures swing without moderation. Its silence offers no cues for biology to interpret. Even with technology acting as a buffer, the underlying mismatch remains. Space habitats must constantly recreate pieces of Earth: air pressure, temperature, lighting, gravity proxies, shielding, all to keep bodies functioning normally. The more completely these conditions are reproduced, the more livable the environment becomes. The farther a habitat drifts from Earth-like conditions, the more biological strain accumulates. This is not a problem waiting to be solved through clever engineering alone. It is a reflection of where humans came from. Attempts to imagine radically altered humans often overlook this timescale. Changing biology meaningfully requires either extremely long exposure across many generations or interventions so profound that they alter what it means to be human. Even then, the results would not be universal travelers, but new organisms optimized for new niches. An adaptation that improves survival in space would almost certainly reduce fitness on Earth. Evolution trades rather than upgrades. Gains come with losses attached. Flexibility has a cost. This explains why space remains unnatural to us even as understanding grows. Tools improve, systems become more refined, yet the fundamental relationship does not change. Humans remain visitors, not natives. Comfort in space is always borrowed, maintained artificially through constant effort. Remove that effort, and the environment asserts itself immediately. Earth, by contrast, asks for nothing. It supplies what the body needs without machinery, supervision, or calculation. That ease is not incidental. It is the product of coevolution between life and planet. Recognizing this does not diminish human achievement. It places it in context. Humans are not weak for being Earth optimized. They are remarkably capable within the conditions that shaped them. Their curiosity reaches far beyond those conditions, even when their bodies cannot easily follow. The universe permits minds to wander farther than flesh, and in that division, something balanced emerges. Exploration continues without demanding impossible transformation. Earth remains home not out of sentiment, but because biology still remembers where it belongs. As the story deepens, this understanding settles gently. Space is not hostile because it is cruel. It is hostile because it is indifferent, shaped by rules that life on Earth was never meant to follow. Humans carry Earth within them, in bone, blood, and nervous system, no matter how far they travel. That quiet inheritance explains both the limits of reach and the strength of curiosity, anchoring one to a planet while allowing the other to roam far beyond it. As the reasons for human limits settle gently into place, a quieter cost begins to surface, one not measured in fuel, energy, or biology, but in meaning itself. Distance does more than separate locations. Beyond a certain point, it severs return. A journey that cannot be reversed changes its character entirely. It is no longer an expedition with an ending that leads home. It becomes a departure without symmetry, a movement forward that quietly erases the possibility of coming back. When return fades from reach, the idea of travel transforms, not through drama, but through implication. Every step outward carries the understanding that Earth will continue without the traveler, changing slowly, patiently, and permanently. Leaving everything behind is not only about distance in space, it is about distance in time. As return becomes impossible, familiar places stop being future destinations and become fixed memories. The landscapes, languages, relationships, and cultural rhythms that shaped a life freeze at the moment of departure. They do not accompany the traveler, they age without them. Home shifts from a location to a recollection, preserved imperfectly, replayed, and softened by memory. The farther the journey extends, the more this separation deepens, until Earth itself becomes an idea rather than a place that can be touched again. This alters the meaning of exploration. Exploration suggests curiosity paired with choice, a willingness to venture outward while retaining the option to return, reflect, and integrate what was learned back into the fabric of one's origin. Exile carries a different tone. It implies permanence, separation not chosen repeatedly, but accepted once and carried forward forever. One-way travel blurs this distinction. Even when departure is voluntary and purpose-driven, the absence of return reshapes the experience. The journey begins to resemble exile, not because it is unwanted, but because it is final. Psychologically, this finality introduces a weight that no technology can lift. The mind is built around cycles, beginnings and endings, departures and reunions. Knowing that a separation has no closure changes how attachment functions. Grief, anticipation, and hope rearrange themselves. Moments gain intensity because they cannot be revisited. Decisions feel heavier because they cannot be undone. The future narrows, not in opportunity, but in connection to the past. Identity begins to float, less anchored to shared places and more dependent on immediate surroundings and internal continuity. This weight does not appear all at once. It emerges gradually as communication delays stretch and shared experiences fall out of sync. Births, deaths, celebrations, and quiet changes on Earth become stories rather than events. Participation shifts into observation, then into historical awareness. Over time, emotional investment must adapt to survive. Some ties soften naturally, others are held tightly, preserved through ritual and remembrance. The traveler learns to live forward without expecting reconciliation between where they came from and where they now exist. This is why distance carries a cost beyond endurance. It reshapes purpose. A journey that cannot end with return must justify itself differently. Exploration driven by curiosity alone begins to feel incomplete. What replaces it is something closer to stewardship, continuity, or witness. The traveler becomes a carrier of culture rather than a visitor to new places. Meaning must be constructed locally, sustained within the journey itself, rather than deferred to a homecoming that will never arrive. One-way travel demands a reframing of success. Achievement can no longer be measured by how much is brought back. It is measured by what is sustained forward. Knowledge transmitted, systems maintained, stories preserved. The traveler's life becomes part of a longer thread, valued not for arrival, but for contribution to an ongoing process. In this sense, distance filters ambition. It asks not how far one can go, but what one is willing to leave behind and what can be carried intact across separation that never resolves. This cost is not a reason to stop imagining travel. It is a reason to understand it more clearly. Distance does not diminish meaning automatically. It transforms it. It replaces circular stories with linear ones, reunion with continuity, return with persistence. The universe allows motion outward, but it also asks something in exchange. When return becomes impossible, travel ceases to be a temporary state and becomes a way of being, shaped by acceptance, memory, and the quiet gravity of choices that cannot be reversed. As the journey stretches farther from Earth, meaning no longer resides in where one is going or where one came from. It settles instead in how one carries the weight of distance itself, turning separation into purpose and irreversibility into a steady, patient form of belonging that exists not in place, but in forward motion alone. As distance reshapes meaning and return fades into memory, the end of the journey does not arrive as a collision with an obvious boundary. There is no wall suspended in space, no final checkpoint where movement is abruptly refused. Instead, travel slows through a subtle thinning of options. Each earlier limit, Fuel, time, biology, energy, entropy, separation, has already done part of its work, not by stopping motion outright, but by asking for more with every step forward. The farther the journey extends, the more resources must be spent simply to maintain what already exists. Energy flows increasingly toward preservation rather than progress. Attention shifts from exploration to maintenance. Small corrections consume larger portions of available effort. The ship still moves, trajectories still hold, but choice begins to narrow. Routes that once felt open now feel heavy. Possibilities that existed in theory slip quietly out of reach, not because they were forbidden, but because they became too costly to pursue. Limits accumulate the way dust gathers on an undisturbed surface, layer by layer, almost unnoticed until movement becomes difficult. No single constraint ever claims responsibility. Fuel alone does not end the journey, nor does radiation, isolation, aging, or distance by itself. Each limit overlaps with the others, reinforcing their effects. The energy required to correct course grows as systems wear. The effort to maintain health increases as bodies age. Communication thins as separation deepens. Knowledge must be preserved more carefully as time stretches. Every solution introduces new demands that draw from the same finite reserves. What remains possible contracts slowly, evenly, without drama. The journey continues, but only along paths that still balance all constraints at once. Over time, those paths become fewer. This is why no single barrier ever ends travel. The universe does not present a final obstacle to be conquered or circumvented. It offers instead a landscape where each step forward subtly reshapes the conditions for the next. Movement remains theoretically possible, far beyond what can be practically sustained. Ships could continue to drift long after meaningful exploration has ended, carried by inertia into an indifferent distance. But travel in the human sense requires more than motion. It requires choice, purpose, and the ability to respond. When those fade, the journey has already reached its quiet conclusion, even if the craft continues onward. The narrowing of possibility happens gently. It feels less like defeat and more like settling. Goals become smaller, closer, more internal. Attention turns inward toward preservation of life, memory, and coherence. Exploration yields to stewardship. The universe is still vast, still present in every direction, but engagement with it becomes selective. The range of viable actions shrinks to those that can be sustained without exhausting what remains. This narrowing is not imposed suddenly. It unfolds at the pace of systems adapting to constraint, learning to survive within thinner margins. In this space, the idea of how far humans could ever travel finds its answer not in distance, but in endurance of choice. The journey stops where choices stop expanding. Beyond that point, motion continues, but exploration does not. The craft becomes a vessel of continuation rather than discovery. It carries forward what it already holds, rather than reaching for what lies ahead. The universe does not object. It simply waits, patient and unchanged by human intention. This ending is quiet because it reflects how limits operate everywhere else. Rivers do not stop at cliffs alone. They thin into channels, spread into deltas, and lose momentum gradually. Lives do not end in every case through sudden interruption. Many conclude through accumulation, through strength that slowly redistributes into rest. Space travel follows the same pattern. It fades rather than fails. Where the journey quietly stops is not a place that can be mapped. It is a condition reached when sustaining progress requires more than the universe can reasonably give in return. Beyond that point, stillness begins to offer more than motion. the story does not close with a barrier struck or a dream denied. It closes with a gentle understanding that possibility, like energy and time, is finite, and that the furthest reach is often not a matter of distance traveled, but of knowing when motion has already said everything it can. As the journey narrows and motion gives way to endurance, something quieter comes into focus, something that was never dependent on distance in the first place. Even when bodies remain close to home, knowledge continues to travel. Light arrives carrying stories from across time. Signals whisper patterns shaped by distant forces. Measurements accumulate, revealing structures far beyond human reach. This is knowledge without presence, understanding gathered not by standing somewhere, but by listening carefully from afar. The universe does not require our arrival to be known. It offers itself through evidence, through subtle clues that cross space freely even when we cannot. Distance itself provides perspective. Seen from far away, Earth becomes small, not diminished, but clarified. Its fragility and rarity stand out against the immense background. From orbit, from interplanetary space, from instruments that gaze outward rather than inward, the planet reveals itself as a singular environment tuned delicately for life. This perspective reshapes priorities. It shifts attention from possession to stewardship, from expansion to care. The farther the view extends, the more connected everything appears, bound by shared laws rather than divided by borders. Space, observed rather than occupied, becomes a mirror that reflects Earth back to itself with greater clarity. Understanding grows without conquest. For most of history, exploration was tied to arrival, to setting foot on new ground and claiming it. In space, that model loses relevance. There is nothing to claim in vacuum, nothing to conquer in radiation and distance. What remains meaningful is comprehension. Knowing how stars form and die, how galaxies assemble, how planets emerge from dust, all of this deepens human context without requiring physical dominance. Understanding allows participation in the universe's story without insisting on control over it. This kind of exploration is quieter and more sustainable. It does not demand irreversible sacrifice or endless growth. It respects the limits revealed earlier, biological, energetic, and temporal, while still satisfying curiosity. Instruments can be built, refined, and shared across generations. Observations can be revisited and reinterpreted as understanding deepens. Knowledge compounds without exhausting resources in the same way physical expansion does. It travels backward and forward through time, enriching cultures long after the moment of discovery. Exploration as awareness rather than expansion also changes how success is measured. Instead of asking how far we have gone, it asks how clearly we see. Instead of tallying destinations, it traces connections. A single observation can reshape entire fields of thought, altering how humanity understands its place in the cosmos. The discovery of planets around other stars, the mapping of cosmic background light, the detection of subtle waves rippling through space-time. Each of these occurred without human presence at their source, yet each profoundly expanded human perspective. This approach aligns naturally with the realities of the universe. Space allows information to move far more easily than matter. Light crosses distances that bodies cannot, carrying detail with remarkable fidelity. By leaning into this gift, exploration becomes an exchange rather than an intrusion. The universe speaks, and humanity listens. Instruments translate, minds interpret, cultures absorb meaning. This dialogue does not require perpetual outward motion. It requires patience, curiosity, and care. Even limits themselves become informative. Knowing where travel cannot go clarifies where attention should rest. The boundaries of reach sharpen the value of understanding. They encourage depth rather than breadth, insight rather than accumulation. Exploration becomes less about spreading presence thinly across vast distances and more about weaving coherence from what can be observed. In this way, restraint enhances meaning rather than diminishing it. What we gain without going far is therefore not a consolation prize. It is a different form of richness, perspective that tempers ambition, knowledge that binds rather than separates, awareness that honors both curiosity and constraint. The universe remains vast and largely unreachable, yet it does not withhold itself entirely. It offers patterns, histories, and laws to anyone willing to look closely enough. As the story continues, this understanding settles gently. Humanity's greatest reach may never be measured in kilometers traveled, but in depth of insight achieved. Exploration does not end where motion slows. It transforms. It becomes an inward expansion of comprehension that makes the universe feel present even at unimaginable distances. In learning how to know without going, humanity discovers a form of exploration that endures long after the need to move has quietly faded. As exploration settles into awareness rather than expansion, the idea of reach begins to loosen from geography and reattach itself to influence. Location matters less than effect. A footprint on distant soil fades quickly, erased by time and environment. An idea, once shared and understood, can persist long after places change beyond recognition. Humanity's reach has never depended solely on where bodies travel. It has always depended on what minds leave behind, on patterns of thought that continue to shape understanding long after the moment of discovery has passed. In this sense, reach is not measured outward from Earth, but outward from insight. Influence travels differently than matter. It does not require propulsion or protection. It moves through teaching, through writing, through shared models of reality that allow people separated by space and time to think together. A single observation, carefully understood, can alter how generations interpret the universe. The recognition that planets form naturally around stars reshaped humanity's sense of rarity. The understanding that time and space are linked altered how motion itself is perceived. These shifts did not involve travel to their sources. They involved attention, patience, and willingness to revise old assumptions. Their impact reached far wider than any spacecraft ever could. Cultural legacy expands this influence further. Stories, metaphors, and shared images carry scientific understanding into human experience, shaping how curiosity expresses itself. When the universe is described not as a collection of distant objects, but as a continuous system governed by elegant rules, it becomes something people feel connected to rather than excluded from. This connection influences art, philosophy, and values, guiding how societies imagine their place in a vast cosmos. Legacy accumulates quietly, passed along in classrooms, books, and conversations, extending reach without movement. Scientific legacy operates similarly. Data gathered once can be reinterpreted repeatedly as tools and theories evolve. Measurements taken generations ago continue to inform present understanding. In this way, influence compounds. Each layer of knowledge becomes a platform for the next, allowing humanity to build vertically rather than spreading thin across distance. Progress deepens rather than disperses. Understanding grows denser, more interconnected, and more resilient to loss of access. This reframing explains why impact does not require distance. A discovery made near Earth can reshape thinking across the universe as thoroughly as one made light years away. Knowing how stars live and die reveals the origin of elements within the body. Understanding planetary climates informs how fragile balance can be on any world. These insights change behavior, priorities, and long term planning without requiring relocation. They reach inward, altering how humanity treats its home as much as how it views the sky. Reach measured in understanding also endures longer. Physical presence fades with time. Machines corrode, settlements decay. Knowledge, when preserved and shared, adapts. It migrates across languages and cultures, surviving the loss of any single location. This durability makes understanding a more reliable vessel for influence than presence ever could be. It allows humanity to participate meaningfully in a universe that resists occupation. In this light, humanity's true reach becomes clearer. It lies not in how far the species spreads, but in how deeply it comprehends. The universe does not reward expansion simply for its own sake. It responds to curiosity expressed through careful observation and thoughtful interpretation. Minds that learn its patterns align themselves with its rhythms, finding connection without conquest. As this realization settles, ambition softens without shrinking. The desire to know remains powerful, but it no longer insists on possession. The universe becomes a partner in understanding rather than a territory to be crossed. Each insight extends reach in a way distance never could, weaving humanity into the broader story of cosmic evolution through awareness rather than occupation. In the end, reach is revealed as a quiet quality. It grows wherever understanding deepens, wherever knowledge is shared, and wherever perspective widens. Humanity's influence stretches as far as its ideas are carried forward, shaping how future generations see the universe and themselves within it. That reach has no fixed boundary because it is not limited by space. It is limited only by the willingness to keep learning, listening, and passing insight onward through time. After drifting through distance, energy, time, biology, and meaning, the original question returns quietly, not as a challenge to be solved, but as a shape now better understood. How far humans could ever travel into space was never only about engines or destinations. It was always a question about relationship, about how a small, temporary form meets a universe vast, old, and governed by rules that do not pause for ambition. The simplicity of the question dissolves because each attempt to answer it uncovers another layer beneath. Distance alone is not decisive. Speed alone is not enough. Survival, endurance, memory, and meaning all enter the frame. What began as a matter of kilometers becomes a matter of alignment between human limits and cosmic structure. The answer resists simplicity because no single discipline owns it. Physics outlines what motion allows, setting firm boundaries through the speed of light, expanding space, and the behavior of energy. Biology adds another lens, reminding us that bodies are not abstract passengers, but fragile systems shaped for one world, carrying requirements that cannot be ignored or negotiated away. Time weaves through both, amplifying every constraint. It stretches distances, accumulates wear, erodes structure, and transforms return into memory. None of these domains override the others. They intersect. A route that physics allows may be biologically impossible. A system biology can tolerate may fail over time. A journey that time permits may lack meaning once return disappears. Each layer shapes the others, narrowing what remains feasible not through prohibition, but through convergence. Seen together, these forces reveal why the universe rather than humanity, defines the terms of travel. The universe decides how fast information moves. It decides how energy degrades. It decides how space itself behaves across cosmic history. Humans operate within those decisions, adapting and learning, but never rewriting them. Technology extends reach, but only along paths already permitted. Ingenuity finds ways to listen farther than bodies can go, but it does not annul distance. Even imagination, powerful as it is, must eventually rest on what reality sustains. The universe is not opposed to exploration. It simply does not rearrange itself to make exploration easy or complete. This understanding reframes the original mystery. The question was never truly asking for a number or a final destination. It was asking what kind of universe we inhabit and what kind of beings we are within it. The answer is not a limit marked on a map, but a relationship traced through constraints. Humans can travel astonishingly far compared to their size and lifespan, reaching beyond their planet with tools and insight. At the same time, they encounter boundaries that are not failures of effort, but expressions of scale. The universe is older, larger, and more patient than any species. It allows moments of movement and understanding, then continues on its own long path. Returning to the question with this perspective softens its edge. How far humans could ever travel into space becomes less about reaching the furthest point and more about understanding why reach takes the form it does. The answer lies in the overlap between curiosity and restraint, between the desire to go and the reality of being shaped by Earth, time, and finite energy. It lies in recognizing that exploration does not disappear when motion slows. It transforms into observation, interpretation, and meaning carried forward rather than outward. In the end, the universe defines the terms not to diminish humanity, but to place it honestly within a broader story. The same laws that limit travel also allow stars to shine, planets to form, and life to persist at all. Those laws make curiosity possible in the first place. Accepting them does not close the question, it clarifies it. The mystery endures, not because the answer is hidden, but because it is layered, unfolding wherever physics, biology, and time meet. So the question rests where it began, now quieter and deeper. How far humans could ever travel into space is not a challenge awaiting conquest. It is a reflection of how a thinking species engages with a universe that welcomes understanding more readily than presence. The terms are already written, not in language, but in structure. To know them is not to surrender ambition, but to align it with reality and to recognize that the furthest journey may not be measured in distance crossed, but in clarity gained along the way. As the story settles into stillness, what remains most clearly is not a map of destinations, but a portrait of a species defined by curiosity. Humanity looks outward not because space promises reward, but because wonder is part of its nature. From the earliest nights spent watching unfamiliar stars to instruments that listen patiently across deep time, the impulse has remained the same: to notice, to understand, to place experience within a larger pattern. This curiosity persists even when limits appear, even when paths narrow, even when return fades from possibility. It adapts rather than retreats. It learns to listen where it cannot walk, to imagine responsibly where it cannot go, and to build meaning from comprehension rather than possession. The universe, vast and indifferent, becomes a partner in this exchange, offering glimpses rather than access, patterns rather than permission. Limits, seen this way, are not disappointments, they are part of the shape of meaning itself. A world without boundaries would flatten significance, making effort indistinguishable from outcome. It is precisely because energy thins, time stretches, bodies age, and distances resist crossing that choices matter. Limits ask for discernment. They shape values. They invite care. The recognition that not everything can be reached does not close the story. It refines it. It redirects attention toward what can be understood, preserved, and shared. It turns exploration inward without making it smaller. Understanding becomes an act of respect, a way of meeting the universe on terms that acknowledge both its generosity and its firmness. There is a quiet beauty in knowing how far we can reach, not because the number is large or small, but because it is honest. Humanity's reach extends far beyond its physical presence, woven through light, knowledge, and memory. It reaches into the past through ancient photons. It reaches into the future through ideas preserved and passed on. It reaches across cultures through shared frameworks that allow people to think together, separated by oceans or centuries. This reach endures even as engines fall silent and trajectories end. It does not require conquest. It does not demand expansion. It grows wherever understanding deepens and perspective widens. The journey explored here does not end with a final answer, because the universe does not speak in conclusions. It speaks in relationships, in balances struck between possibility and constraint. How far humans could ever travel into space becomes less important than how humanity chooses to engage with what lies beyond. Motion is one form of engagement, awareness is another. The latter endures longer, asks less of fragile systems, and aligns more closely with the realities uncovered along the way. It allows humanity to remain present within a cosmos that is too large to be crossed, yet rich enough to be known. As this reflection draws gently to a close, the story leaves behind no instruction and no verdict, only perspective. A sense that limits do not diminish wonder, but focus it. That curiosity does not require endless movement, only attentive minds. That meaning does not reside at the farthest edge of reach, but within the clarity gained by understanding the shape of that reach. Humanity remains a small presence in an immense universe, yet one capable of remarkable insight. In accepting where travel slows, exploration continues in quieter forms, carried forward by learning, care, and the simple act of looking closely. And so the journey rests here, not because there is nowhere else to go, but because there is much already seen. The universe continues its long unfolding, patient and unconcerned with whether it is visited or merely observed. Humanity remains beneath the stars, still curious, still listening, still finding beauty not in how far it travels, but in how deeply it understands.